Okay, we're going to use some expensive equipment in our downtime to prove some theory behind fuses. This is a 10 amp fuse. It's in a fuse holder. We're using some pretty light gauge test leads and a jump pack to power it. You're going to see how much amperage actually goes through a fuse when it burns, and the differences between a 10 amp fuse and a 20 amp fuse, so you can really understand what's happening when a fuse is getting burnt and why it's so important to use the right size fuse for whatever that circuit's designed for. So we're going to go ahead and blow that 10 amp fuse now. And you can see here that lasted about 30 milliseconds, and it peaked out here at about 65 amps, and that's about all we got out of that one. So 65 amps out of a 10 amp fuse before it blew. Now we're going to go ahead and do the same thing with a 20 amp fuse. So we went ahead and changed that. So we're going to go ahead and blow that one. And you can see the amperage stayed relatively the same. The only difference is the burn time increased quite a bit. Get that lined up so you can see it. You know, that burn time is actually about 100 milliseconds, which is quite a bit longer, but you see the amperage stayed about the same. The reason for that is the amperage that the circuit can provide is maxed out. This is a really kind of a bullshit setup, but you can see we're maxing out the amperage of the test leads and all the connections, and you're actually burning that fuse over time at max amperage for the circuit. So whether you have a 10 amp fuse or a 20 amp fuse, before that fuse burns, you are maxing out the amperage on that circuit, and the fuse just happens to be the weakest part of that circuit. Now, if the fuse wasn't the weakest part of the circuit, we could start something on fire, or the whole thing on fire. We'll melt these leads right off, or we'll start a fire at one of these alligator clips. But because the fuse is doing its job, it burns first. So, some useful information, but, really, just use the right fuse.